Yeah, welcome everybody here. I'm today talking about meta transactions, and yeah, I want to give you an overview based on an example how to frictionless onboard new users to a blockchain with, in case of Eternity, we have some native transaction type called PayingForTx, and I will show you very soon what that means and how it's maybe better than other solutions out there which don't have this kind of transaction type. So yeah, give you a brief introduction in the use case I want to present you. As use case, I want to use a play-to-earn game. I mean, that's also something coming more and more. You want to onboard people earning their items or coins or whatever and doing something with that. You can trade it, you can do whatever you want, but you need to onboard a user somehow. And then I will show you the usual onboarding journey, how it looks like in most cases. And I will show you why meta transactions are the rescue to that. So you can use that specific mechanism to make it more easy to onboard new users to your game. Yeah, that's another thing. Then I want to show you how it's most of the time done on Ethereum or EVM-based chains. And last but not least, I will show you our approach and why it's probably superior. Yeah. All right, let's jump in the use case, play to earn. So let's assume you have some new, cool, fancy game that you developed on the blockchain. You want users, you want to onboard users. They can play your game, they can do something in the game, and then they earn some tokens. So they probably created their wallet already, they back up their seed phrase, but they don't have any coins at that point of time. And then you send them some, based on their gaming activity, you send them some tokens which they earn through gaming. But then what? Yeah, they probably want to do something with their item and they will probably struggle with that a bit because that's what I show you on the next slide. What's the typical user onboarding journey in that sense? Yeah, so somebody discovered your app. Maybe the first two steps were already done because he's already playing that game, like in the first slide. He maybe already earned some tokens, but now he has to do something, and that's the point 3 where we then go on, because people need to somehow get the native coin of a blockchain because there are always transaction fees involved. Otherwise the blockchain would be spammed completely, or could be spammed completely for free, which you want to avoid typically. So yeah, somebody has to pay a fee to get some transaction included in the blockchain, and this is usually done in the native token of that blockchain, and you need to give it in the hands of the users somehow. Okay, but what do you tell your users then usually? Yeah, you need to register on exchange XY. You probably have to do KYC there, like the usual process. Meanwhile, back then it wasn't always required. It's coming more and more, so you could assume that you need to do it. And then you have to transfer fiat, USD or euro to that exchange, either via credit card or wire transfer. And if finally the money arrived at the exchange and they confirmed it, sent you probably an email that the money arrived, then you can trade it to some token. If you're not one of the big blockchains, which are probably Bitcoin or Ethereum, you would maybe have to do another trade there, because you first have to trade euro or USD to Bitcoin or Ethereum, and from that coin then to your native blockchain coin, in our case AE. And if this is done, you can finally withdraw your crypto from the exchange to your wallet, which enables you to transact on the blockchain. So for new users, if you want to have mass adoption, that's pretty a hurdle. And yeah, the rescue for that are meta transactions. So what's the meaning behind that? I just read it out here. Meta transactions are transactions whose data is created and signed by one person and executed by another trusted party, the relayer, who pays the gas fees. So yeah, this is basically what, I hope it's quite understandable. So people can just transact and do what they want, but they have somebody else paying their transaction fee, which is required for the blockchain. So what this means in the case I've shown before is like you eliminate more or less all the steps that come after downloading a wallet and backupping the seed phrase or whatever. You don't need to get the native coins from some exchange. So you as game provider could cover the fees, the onboarding fees of your users, and this way they can get started quite easily. How does that look like on Ethereum or EVM-based chains at the moment? There is some standard. So the problem here is that the protocol of Ethereum is not knowing about that concept. So you have to do it within contracts, you have to create your own protocol, and this is the de facto standard protocol which I'm describing here. It's basically like I described it, so some user signs a transaction and sends it off-chain to the relayer, and the relayer then covers the gas fee. And there's some tricky part because you cannot make any contract out of the box. I mean, if you have already a smart contract deployed on the blockchain, it's not aware of that meta transaction protocol. So that's a bit the tricky part. Yeah, Hans maybe wants to add something. And yeah, that's the tricky part here. So you have to make your smart contract aware of that concept that you can even do it. So yeah. And then you have to have another trusted forwarder from whom the transaction is being broadcasted to the chain. And yeah, there is some problem with that. I don't want to go into details. I just want to show, I want to present the solution, right? So this is quite an overhead, which is not necessarily needed. So here's another diagram how that looks like. You have the transaction signer who wants to sign the transaction. You have the gas relay that covers the gas fee. Then you have the trusted forwarder who broadcasts the transaction. And you have to have a smart contract which is aware of that concept and has included the trusted forwarder to only accept these transactions from this trusted forwarder. So there's many things involved we don't really need and which we provide a way better solution in my opinion. So this is why I want to introduce you the Aeternity's native paying for transaction. I'm not sure from which hard fork on we support it already. I think it's this the last one, Iris? Yeah, so we introduced it in the Iris hard fork. There was a community request quite some time ago from a wallet provider who wants exactly that, frictionless user onboarding, who asked for that feature, and then we Hans implemented it. Yeah, and I'm really a big fan of that. We're already using it in some places, like Jan showed the GA multisig solution we implemented where we use a generalized account, and there we use that feature somehow to convert a regular account to a generalized account that doesn't have any balance. So that is quite fancy there. So if you missed that talk, maybe watch it live. I think it's recorded or should be recorded. Yeah, but how is that different what we provide? So we have that paying for transaction type natively, which means the protocol supports it out of the box. You can just sign any transaction you want on the blockchain. You just have to sign it in a specific way to avoid on-chain replay attacks. So there's a difference in how to sign the transaction. But if you sign it that way, you can move the transaction to some relayer who then wraps it into the paying for transaction type and signs this transaction and broadcasts it to the blockchain. And we don't need any modifications in the smart contract. I mean, if it's a contract interaction, which is most likely the case, but we can do it for any transaction type Aeternity supports. There are quite a bunch, so if you look in the protocol, you will find many different transaction types, but this is mainly about contract interaction stuff. So yeah, compared to the EVM-based solution I've presented before, this is much more smoother, and the most important thing here is really that no contract needs to be aware of that concept because the protocol just supports it out of the box. And for the technical people here, one small example which uses our JavaScript or TypeScript SDK to create or showcase. I mean, it's in the documentation. If you look in the documentation and the user guides of the JavaScript SDK, you will exactly find that. So I can shortly explain for everybody not understanding it immediately. So we're first preparing the contract call for the person or account not having any AE balance. So we are calling a smart contract, which is in this case called PayingForTx example. And there we call a function called setLastCaller. We build that transaction, we sign it in that specific way. This is why we give in the options the inner transaction true. And if this is the case, we can forward this signed transaction to some relayer or the payer. And the payer then creates the paying-for transaction and broadcasts it to the network. And if we then make a dry run on the getLastCaller function of the contract, we see that the person who signed the contract call transaction who not paid the fee was the last caller without having any balance of AE. Yeah, so thank you everybody. That's already the end.